x squared plus 6y squared equals 49. X minus 2y equals 1. Let's start by solving for a single variable. In this case, this x is a prime candidate. So let's rewrite this as x equals, notice I can add 2y to both sides, so x would equal 2y plus 1. Let's substitute this into our first equation. So instead of x squared, it would be 2y plus 1, quantity squared. Now for the rest of it, plus 6y squared equals 49. Next, let's expand this binomial. So 4y squared plus 4y plus 1 plus 6y squared equals 49. Now let's combine like terms and further simplify. So 10y squared plus 4y, and if I subtract a 49 from both sides, I get negative 48 equals 0. I can try to factor that, but before I do, let's see if we can simplify by factoring something out first. In this case, a 2. So it would be 2 times 5y squared plus 2y minus 24 equals 0. And that 2 can actually go away, because if I divide both sides by 2, 0 divided by anything is still 0. So 5y squared plus 2y minus 24 equals 0. And this I can factor. This will factor to 5y plus 12 times y minus 2. Setting each of these pieces equal to 0 gives me 5y plus 12 equals 0, or y minus 2 equals 0. Subtracting 12 from both sides, I have 5y equals negative 12, and dividing both sides by 5 gives me y equals negative 12/5. Or, if I add 2 to both sides, I have y equal 2. So here are two y's for which I need to find the corresponding x's. Remember that x was equal to 2y plus 1. So if y equals negative 12/5, then putting that in, x equals 2 times negative 12/5 plus 1. X equals negative 24/5 plus 1. Or x would equal negative 19/5. So I'd have the solution negative 19/5, negative 12/5 as one of my answers. If y equals 2, then x will equal 2 times 2 plus 1, or x would equal 4 plus 1, or x would equal 5. So I'd have the solution 5, 2. So my solutions are negative 19/5, negative 12/5, and 5, 2.